All right, guys, let's try this. I have a new setup. I almost did a webcam so you guys can see my face, but I figured you see that enough. You don't want to see it again. So here we go, guys. This is the last set of notes for the unit. So we are going to describe, still in 1.3, so we're describing the quantitative data with numbers. You know what? I'm going to shrink this up a little bit and see if that works a little bit better. Uh, I'm on a bigger monitor, so I can actually write hopefully a little bit better. So what we're going to be doing is we're kind of piggybacking off of the 5 number summary and those things. So if you guys remember, right, real quick, we have our 5 number summary, and we have something like this, and we have our Q3 and our Q1, and we have our median, and then we have our min, and then we have our max. That's our 5 number summary, right? So we know for spread, let's say, we know for spread that Q1 and Q3, the difference between those is the IQR. And we know that contains 50% of the data points. The data points. All right. So, but again, that is literally only for skewed right and skewed left. That one's a little bit better. So we can only use the skewed ones with that one. All right. So now, what about normal? What about symmetrical? You'll hear me talk about normal a lot. Normal and symmetrical mean the same thing. I like the word normal because we actually start talking about normal graphs here soon and checking for normality and all these other different things like that. So let's tackle this. So we're going to move on to the next piece. So we look at this data set. I got a dot here, 2 of them here, one there, one there. So they're equal distance, nice and even. So 4 is literally my mean. And we call that the balancing point. Okay. That's the balancing point of the equation. So but remember, to get to the mean, we're going to take all the data points. So we're going to take the sum, that means add them all up, of all the x data points. These are all the x ones here. So like that's x1 and that's x2 and that's x3. We're going to take the sum of all those and we're divided by n, the number of data points. Okay, that's how we find, this is sigma. It's the sideways, it's not sigma, sorry. I can't even think of what it's called right now. It's the sideways summation notation. So we're going to sum or add all these up together. That's how we get the mean. So now what we've got to worry about is, let's see here. Now what we've got to worry about is how do we measure spread around the mean? Because if this one up here, IQR, this guy up here, that is measuring spread around the median, right? So now we got 25% on this side of the median and 25% on that side of the median. So what do we do here with a non-resistant data point, which is mean, right? So our mean is our balancing point. So how do we tackle this? So we know that 4 is the mean, and I'm going to put X bar right there. We know that X bar is right here. So here's my question. How do we measure spread? Well, what we do is we say, oh, how far away is this? Well, that's 1. How far away are those? That's 2, but there's 2 of them, right? And then how far away is this one? Whoops, too far. That one there. That's 3 away from the mean. And then if we do the same thing here, we have a 1, we have a 2, and we have a 3. Now, if we give them direction, and we give this one a -3, and this one a -2, and this one a -1. Well, if you look at it, if we went to add all these ups, add all these ups, add all these x values up, or sorry, the values from the mean, and tried to find an average, it wouldn't work because we get zeros. -3 plus 3 is 0. -2 plus 2 is 0. -1 plus 1 is 0. So it's like, okay, wait a sec. How do we deal with that then? Because we've got negatives here. So there is a specific way we deal with it, and that's called standard deviation. So here's the deal. Standard deviations are how far the values in a distribution are from, I'm gonna cross this out. I don't like using the word average right there. So let's cross that out. You guys cross out average. How far the values of in a distribution, this is a distribution, are from the mean, the balancing point, on average. So basically, we're going to come up with some way to add all these together to get us to an average distance away from the mean. And you can kind of see it's going to be right around 2 here, because if you balance these out, it's the average of this. So let's just try this one here. 3 plus 2 plus 1. That's going to be what? 6. 6 divided by 3 is 2. But there's 2 data points, so it's really not that. You'd add it 2. So how do we take care of all that? Well, we take care of all that by learning how to calculate the standard deviation. And this is what it looks like. Okay? So this is what the standard deviation looks like. This is the long version. We have x1 minus x bar plus x2 minus x bar. Sorry, x bar, not x1. Get rid of that. Okay? Let me get rid of that for you guys. Let me just go backwards. So x bar. And then we add it with x3 minus x bar. Okay? Kind of see the pattern here? So let's talk about that. So if I go x1 right here, let's call this x1, and I subtract it from x bar, which I did already, so x1 minus x bar is equal to -3. Man, but I said, how do I deal with negatives? Because just on the other side, there's a positive, and they're going to cancel each other out. It makes no sense. Well, easiest way to get rid of a negative is to square it. Square it. Square it. So we subtract these things and we square them, okay? And we're going to add them all up. So let's clean it up even more, all right? So let's go. Let me show you the long calculation here. So the standard deviation is equal to, for this one, is going to be x1 minus x bar squared plus x2 minus x bar squared plus x3 minus x bar squared, dot, 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 and so on, right? And we're going to divide that by n minus 1. Here's the trick, though. If I square this, if I square all these, all of a sudden my units are squared, okay? So like if we're talking about pets, this set of units would be pets squared. That unit, let's say this is the number of pets people had. That unit, pets squared, makes absolutely no sense. It's like, that makes no sense. So I'm 4 pets squared away from the median. I'm sorry, from the mean. That doesn't make any sense whatsoever. So when we deal with standard deviation, we just take the square root of our answer, which is just takes care of that. So now the number, I should say the number of pets squared. Now all of a sudden, it's no longer the number of pets squared, it's the number of pets. So we take the square root to bring it back to the correct number of units. All right, so that's the basic idea. We're going to take the first data point, we're going to subtract it from x bar. We're going to take the second data point, subtract it from x bar. We're going to take the third data point, subtract it from x bar. And you have to account for all of them. How do we deal with the negatives? We square them. All right, so now let's tackle this next piece. So uh, variance is just the unsquared version. So variance is equal to standard deviation squared. So it's without the square root. We don't use it because of this. So this would be variance. The number of pets would be standard deviation. Okay. So variance we don't use. It's just the average difference of the squares. So uh, we don't really deal with it that much. So don't worry about variance. It's just like I said, it's not that big of a deal. So uh, range, IQR, standard deviation. So if we're talking about similarities, they all measure the variability. Or if we're dealing with our SOX acronym, right? If we're dealing with our SOX acronym, make this a little bit bigger, we are dealing with spread. Okay. So they all measure spread, every one of them. Some are better than others, but they all measure spread. Now, oops, like that. I'll just leave it. So why is that not disappearing? There it goes. So what's the difference? The difference is their resistance to outliers. So range, which we don't use, and standard deviation are not resistant. Okay? Our IQR is resistant. All right. I did it in big letters because that's super important. Okay? So these three measure spread. We really don't use range that much. We really focus on those two. All right? Now, here's the best part about statistics, guys. This is literally the best part. And those of you that had calculus already, remember all those stupid formulas we had to memorize and all that crazy stuff? There are no formulas to memorize in here because this formula that I'm going to give you is on the formula sheet. I'm going to give you're probably getting the formula sheet in class. That's because it can get super ugly. So you need to have calculators ready to go. So let's go back up here. This is what I mean by super ugly. If we're subtracting every single data point from the mean, what if there's 50 different data points? That means you're doing this 50 different times by hand. That really, really would be horrid. Okay. So this is what we're going to deal with. So let's talk about a few things here. It's on the formula sheet. I'll get to that in a minute. So when we're dealing with the data points, remember this is mean. I'm going to write it over here. X bar is the sample mean, and standard deviation of X is the sample standard deviation. And then mu is the population mean, and sigma is the population standard deviation. That's the difference in the symbols. So X bar goes with the standard deviation of X, mu goes with sigma. All right, now here's the deal. And I talked about this earlier. This is the whole basis of statistics. These are called estimators because they estimate the population. So samples estimate the population. Whoops, Control Z. Samples estimate the population. Can I tell you guys right here without getting too far into it? This setup right here, what I just said, samples estimate the population, is one of the issues with the COVID data and the vaccine data and everything else that's out there. People don't understand in general that certain samples estimate the population, but there is an area for error, and that's usually what gets picked up by social media. I'm not going to get too far into it, but as you guys go through class, you guys are going to see that data can be manipulated because these are only estimates for the population, and we can talk about that if you guys have some questions. But it's not just COVID data. It's just that's the one that's prevalent in the news or has been prevalent in the news. And that's where it all fell apart. So if people kind of felt like they were getting crazy about that point, that's because by the end of class, you will understand why people didn't understand, why people did not. Let me rephrase that. By the end of this class, at the end of the year, you'll have a knowledge of why people didn't understand the numbers that came out and got crazy about the numbers. Okay. So this class is super applicable. I'm telling you guys, got to get through this first couple of chapters and it starts smoothing out. Okay. So here's the key. You must show how to calculate. That's the biggest thing I'm going to tell you is you got to show how to calculate it. I'm not going to tell you you will not have to prove or show every data point calculation. Okay. So you have to show how. So here's the formula, and they've changed the formula sheet. So we'll find it on the formula sheet, but here's the formula sheet that you got to deal with. So the standard deviation of x is equal to the square root of the sum of all the x values. You may see it in a book. This means like the different x values. You can change I to 1, 2, 3, 4, 5, 6, all those different numbers, minus x bar squared over n minus 1. You have to show that if you're calculating with your calculator. You can't just put calculator numbers down. You have to show that you understand what it means. So when you use a calculator, that must be on there, okay? So we're going to get really, really close here, and then I'm going to have you guys, we'll do this one in class, but I'm going to show you what it looks like, and then you can calculate it. All right, so here we go. So here's the last few things, guys. Well, what color have I haven't used that color. We'll see if it's ugly. So what are some properties of standard deviation? First of all, it measures the distance around the center. What's the center? Mean. Very specifically, it's the distance around the mean. Only when mean is chosen as the center, period, end of story. Standard deviation cannot be used with anything else. All right. It's always greater than 0 because that means it would be literally all the same data points if you guys think about it. That is why we square the point minus the center. In other words, that's why we square x1 minus x bar. So because it would be 0 at that point. Okay. It always has the same units of measurement as the mean. So if the mean is in pets, if x bar is in pets, number of pets, standard deviation is in number of pets. That's why we take the square root for the standard deviation. It is not resistant at all, just like the mean. So therefore, we can only use it with these guys. If you see skewed, you can't use it. All right. So let's look at what it looks like here. Here's the example we're going to talk about in class, and we'll interpret it in class because there's a little bit of a sentence that we got to deal with, and it's kind of like a fill in the blank sentence for you guys. So here we go. Sorry, I moved it up and down. So I'm going to find the standard deviation of this. So first of all, how many data points do we have? So we're going to write n equals 5. Okay, that's our n. So the standard deviation is equal to the square root of x minus x bar squared all over n minus 1. The n minus 1 is inside the square roots, guys, okay? Which is equal to, check this out. We have to know the x bar, and I don't know the x bar off the top of my head. So this is what I'm going to set you guys up with, okay? All right, let me change the color here because I don't like that color anymore. It's dumb. Let's do that one. I'm going to take the first data point, which is 0, and I'm going to rewrite the square root. You ready for this one? This is amazing, guys. 0 minus, and then you guys need to fill in the x bar. Use your list and fill in the x bar. I don't have it with me, so we're going to put our x bar there, squared, right? This is going to be x bar, plus, you ready? You guys ready for this? Oops, I forgot one part. Right here in front of this, put a little summation notation there, okay? The sum of 0 minus x bar plus 25 minus x bar again squared. Here it comes, guys. Biggest deal in the world. Best time saver ever. Dot, dot, dot. All over 5 minus 1 equals whatever your calculator spits out. Okay, so you're like, oh, why do I have to do that? Okay, first of all, remember, they have to know you know the concept. So what you're saying here is, I know the formula off the formula sheet. I know how to find n. I know where to find the formula on the formula sheet. I know the formula means the first data point minus my x bar squared plus 25, the second data point minus my x bar squared. And then dot, 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 I'm letting the calculator do the rest of the work. So all you would do is put your answer here of, this would be, remember, this would be in minutes, and then we'll interpret it in class. Okay? All right, guys, this will be kind of what we're doing here. So now, here we go. What factors should you consider when choosing summary statistics? The shape. Remember, mean and standard deviation go with symmetrical graphs. 5-number summary, go with skewed graphs. All right? Okay, guys. That's our homework for tonight. Remember, calculators are our friends, not food. There you go. That's a movie reference. See you guys soon. Maybe if I can turn it off. There you go. Bye.